Hello and welcome to Module 3. So this week we'll be talking about consumer choice, and the big picture here is that after we have thought about supply and demand, which is a way of trying to model what's going on overall in a market, which is important for understanding how we can manage things well as a firm within that market, we want to look more in depth at both sides of the equation. And so Module 3 is really about trying to understand what's going on underneath the demand curve. So at the root of what's going on with the demand curve, we have this relationship between the price and how much consumers want to buy that good or service in the defined market. But at a more granular level, what's really making that up is a whole bunch of individual consumer decisions about how much to buy of one good versus how much they want to spend of their limited budget on other goods and services. And so that relationship between price and quantity demanded is going to depend on how much consumers value one thing versus another as they consider their limited budget and the prices they face for different things. And then if you add up, of course, what each consumer is willing to buy at a given price, you can get the total quantity demanded and start to look at that overall market demand curve. So for us to make good decisions as managers of firms, we need to think about what are consumers going to do in response to the choices we make in terms of setting prices or choosing how much to produce. Of course, in reality, there are all sorts of complicated things that drive consumer choice, and the economic lens is really just one lens we can use to understand consumer choice. Now, with the economic lens, we're kind of assuming that consumers are rational and they're trying to weigh out how much they value different things and consider the price of the things that they're potentially going to be buying. In reality, there's all sorts of complicated psychological factors that affect consumer choice, but I think it's fair to say that part of the puzzle is understanding what a rational person would do as they try to consider allocating scarce resources. And considering that piece of the puzzle will help us understand something about consumer choice, and that simplifying assumption in the model also helps us better understand how to aggregate individual preferences to describe a whole complicated set of interactions, say, in a demand curve. All right, so this week we have 5 learning objectives. First, we want to consider the idea of utility and the properties of indifference curves. And so utility is basically just going to be the idea that when consumers buy things, they get some usefulness or satisfaction from whatever they're buying. So utility is basically just putting a number on how much consumers prefer something. And if we think about how much they prefer one good versus another, indifference curves will show us all sorts of combinations of different goods that get consumers to the same amount of overall utility or satisfaction. And so that helps us think about how much they value one good versus another when they already have certain amounts of those goods. Next, we want to describe how budget constraints affect consumer decision-making. So we really have 2 aspects to consumer choice. One is related to preferences, how much the consumers value one good versus another. And then the second part is going to be related to the cost, and that is what we're looking at in our budget constraints. So we're trying to consider what's the cost of buying one good? Well, it has to do with the fact that you have a limited income or limited budget to spend, and there's a price for buying that good. So the budget helps us understand that relationship between buying one thing versus another when each good has its own price. Then we want to see, when we combine preferences and costs, how consumers would try to maximize utility. And if you think back to our discussion of optimization in Chapter 3, this is really following those same principles, and this is what we call a constrained optimization problem. It's constrained because we have to stay within our budget, and then we're trying to optimize by thinking, as the consumer, how do we try to get as much satisfaction or usefulness or happiness as possible with our limited budget. Next, we want to look at elasticity of demand, and that's going to be useful for helping us to predict changes in quantity demanded and total revenue. So understanding how consumers will change how much they're buying as we change the price of our product is really important for predicting what's going to happen as we change our price, and it's really important for trying to decide what the optimal price to set would be as we try to say, maximize revenue, and ultimately, eventually, we're going to try to be maximizing our profits. Okay, and then we can kind of calculate these different elasticities. We'll talk about what elasticity is, roughly speaking, here in just a second. And then lastly, in Chapter 7, we'll be looking at some ways of estimating demand using real data. And this is really useful as we try to think about not just some hypothetical demand curves using our economic theory, but how would we in the real world take some data and try to figure out, as we change the price of our product, how is that going to change how much people are going to buy? Okay, and so this week, due Thursday, we have a reading reflection related to a podcast here and a short article. And so that will help us consider consumerism from a Christian perspective. I think it's useful to consider the ways in which it sort of makes sense to think about consumers as just rational maximizers trying to make the most of their budget, and how also from a Christian perspective we need to think about people in a little bit of a broader way and consider factors like, how does taking a consumeristic mindset affect how we interact with other people in the world and how we relate to ultimately God and the resources He's given us in life. And so that gives us some things to think about with consumer choice. Then for Monday, we'll have kind of homework going through these 3 chapters. I'll give you a brief overview of these 3 chapters related to consumer choice, price elasticity of demand, and estimating demand curves. And then we'll have a chance to analyze some demand data in Excel with kind of a preset example that will hopefully give you a good idea of how we could try to estimate a demand curve using some data. And then kind of looking ahead, we're going to have an assignment in Module 5 where you talk to a manager and ask them a little bit about how they actually think about things like setting prices or how much to produce of a good, and kind of relating that to our economic models. So economic models are useful in that they help us focus on important things and kind of get rid of some of the complicating details of real life. And so economic models are useful for analysis, but it's also important for us to think about what people do in real life. And so that's kind of what this assignment's about. So that will be coming up at the end of Module 5, but for this week, I just want you to identify someone you can talk to so you kind of have time in advance to set up a short amount of time to meet with them. All right, and then lastly, at the end of this module, we're going to be having our Zoom meeting. So this is the time that seemed to work for the most people. For a couple of you, if this time doesn't work very well, just reach out to me and we'll try to make the best of it. But hopefully most of us, this time should work for our class Zoom meeting. So I'll be sending out a Zoom link for that, and we'll kind of just discuss what we've learned so far and try to address any questions and things coming up with our first test, which will be due at the beginning of the next module. So Thursday night, this would be the 14th. All right, so that's kind of a look ahead. So to give you a brief overview, Chapter 5 is about the theory of consumer behavior. And so we're going to make some basic assumptions here. One of the more important assumptions is that we're thinking about using math in a theory to show how theoretically a rational consumer would want to maximize utility or usefulness on a limited budget given a set of prices that they face to buy things. And so we're going to define some terms in this first section and think about utility. That's like our usefulness or our satisfaction that we get from a combination of goods. Maybe it's 4 apples and 2 oranges or whatever the bundle is. And we'll think about our budget constraint, which shows us how much we can afford of different combinations of goods based on our income and prices. And then we'll kind of move ahead to trying to figure out how we can graph these things and use that to think about the optimal amount for a consumer to buy of a good. All right. So we'll look at indifference curves. The idea of an indifference curve is sort of like this. We're going to be thinking about 2 goods. So we'll call this, just to keep it abstract for now, this will be good 2. This is good number 1. And so for a consumer, we're always thinking about buying one good versus another. That's really what's going on underneath the demand curve. And when we think about the market for a specific good or service, what's driving that choice of should I buy more of this thing or not as the price goes up is kind of this underlying decision of I have a limited budget and I have to consider how much I want to allocate to buying one good versus another good versus all sorts of other goods. And of course, in reality, we have lots of goods to choose from. But to illustrate the basic idea, it's helpful just to consider what if we spent a limited budget on one of two goods, and how do we think about how we'd allocate our budget to buying a combination of these two goods. So we could buy more of good one, we could buy more of good two. We're probably going to buy some amount of both, depending on how much we value these goods. But an indifference curve is going to tell us all the combinations of these two goods that make us equally happy, or we equally prefer all these combinations. So maybe, for example, we could look at this combination where we have 5 of good 2 and 1 of good 1. Maybe we equally prefer that to this combination here where we have 3 of good 2, 2 of good 1. Maybe we equally prefer that to, let's say, having 1 of good 2 and 6 of good 1. And we're going to think about all these combinations along a curve like this, and that's our indifference curve. There's sort of two basic assumptions we want to think about with this indifference curve that shows us all the combinations of two goods that we're equally preferring. One, we're going to generally assume that more is better. So that means that if we have more of both goods moving up and to the right, we're always going to be preferring moving up and to the right, getting more of both, rather than having less of both. So for example, if these are all the combinations that we're indifferent between on this line, if we consider another bundle, like maybe we have, we have 5 of this one and 6 of this one, we should prefer this one more than any of these combinations over here. Having more of both is definitely better. And for that reason, we're going to need a different indifference curve that shows us a higher level of utility or satisfaction when we have more of these goods. And so because more is better, that means that these indifference curves are always moving closer to the x and y axis, because if we say we start to curve this inwards like this kind of violates our more is better assumption, because in this case, we'd be saying we're equally preferring this good combination and this good combination, even though this one here is clearly more of both goods. It's up and to the right, and so those ones should not be equally preferred. 2, we usually assume, not always, but quite often, that there's diminishing marginal utility. And what that means is that when we have a lot of good 1, we don't care as much about getting more of good 1. This basically means the more you have of a good, the less you care about getting more. I think this is a fair assumption to make most of the time. If you have 1 donut, that might be all well and good, but once you've already had 5 donuts, getting a 6th donut doesn't really provide that much more utility or happiness. And so because of diminishing margin utility, we often assume that the indifference curves have this kind of bowed inward shape, because when we have a lot of good 1, the slope here is going to be flatter, meaning we don't care that much about getting more of good 1, we care a lot more about getting more of good 2. And when we already have a lot of good 2 and not much of good 1, in that case, the slope is a lot steeper and we care a lot more about getting more of good 1. So if we don't have much good 1, we get a lot of utility from getting an extra unit. If we do have a lot of good 1 over here, that utility of an extra unit, the margin utility, is going to be a lot lower since we already have a lot of the good. All right, next we can think about our budget constraint. The basic idea here is that we have some income, and then we have prices of our two goods, call that price 1 and price 2. And so if we think about the same space of good 2 versus amounts of good 1. Our budget constraint shows us what are the combinations we can afford. And so if we spend all of our money on good 1, how much can we buy? Well, however many dollars we have in total, our income, divided by the price of good 1. So if we had $100 to spend and the price is $10 per unit, if we spend all of our money on good 1, we could afford 10 units, right? And then we want to consider, well, what if we spent all of our money on good 2 and we got 0 of good 1? Then we'd be over here. And the most we can buy of good 2 is whatever our income is divided by the price of good 2. And this budget constraint looks like this. That's our budget line. And it shows us if we're spending all of our money on these 2 goods, these are all the combinations that we can afford. We could spend all of our money on good 2, all of our money on good 1, or more likely than not, if we have diminishing marginal utility, we're probably going to pick somewhere in the middle. Okay, and then for utility maximization, we're trying to think about getting the most utility while staying within our budget constraint. Okay, so if we have this is our budget line, let's say, and we have some indifference curves, we have indifference map is going to be all the different indifference curves. So maybe we're indifferent between all of these combinations, and then we're at a higher level of happiness, but indifferent between all of these combinations and all of these combinations. What we're looking for is how do we get onto as good of an indifference curve as possible while staying within this budget constraint. So for example, this budget line here, we could afford this point or this point, but it's not going to maximize our utility because any point in the middle is going to be on a higher indifference curve. So for example, if we look at this indifference curve here, we can see that we can get as far up and to the right as possible by going to this point where the indifference curve is only touching the budget line at one point. So this is what we mean. Tangent. Tangent means touching at one point. So we want our budget line to be tangent to our indifference curve. And so the other thing that we know is if it's touching at one point, we know that the slopes are equal. That's sort of a calculus thing. And so what we're going to see is that at this optimal point, the slopes are equal. And the slope of our budget line is just the ratio of prices. The slope of our indifference curve is related to the margin utility of each good. And so what we can do is we can write this like this. When we're at the optimal quantities, so we're at our optimal combination of each of these 2 goods, that would be here in this case. If we're at our optimal quantities, then it should be the case that the ratio of margin utility to price for these 2 goods should be the same. So the extra utility we get from one more unit of the good relative to the price of that good should be the same for all the goods we're buying. If not, we want to buy more of whichever one has the higher margin utility per dollar, which is the margin utility divided by the price. Because if we have the margin utility related to the price is higher for one than for the other, we want to buy more of this thing. As we buy more of that thing, that eventually the margin utility will go down due to diminishing margin utility until we find this point of equality. So we could afford combinations over here or over here, but we want to keep moving towards this middle point to get on the highest indifference curve possible. And then at that point, these margin utilities per dollar should be equal. All right, then we can look at individual and market demand. And the basic idea here is that if we look at quantity demanded for the whole market, that's just going to be the sum of how much each individual consumer wants to buy. So if we have n consumers, what we do is we just look at a given price, how much does each consumer want to buy, and if we add that up, that'll give us our total quantity demanded. So we can think about quantity demanded as a function of the price, and that's just going to be adding up over all the consumers how much each individual wants to buy as a function of that price. So we can figure out how much an individual consumer wants to buy of different goods when we look at their utility maximization in the last step. And once we think about that, we can look at, as prices change, how does that change the optimal consumption bundle for each individual? And we just add up how much each person wants to buy to get the total amount that consumers would buy in that market at a given price. Of course, there's one caveat here, which is corner solutions. So in some cases, for the most obvious cases, if we have goods that are substitutes, if goods are substitutes, like say for example, we have like Pepsi and Coke, then the indifference curves might look a lot like straight lines. Because if we have Pepsi and Coke, we might have some constant rate at which we're willing to trade off one for the other. If we like them both equally, then we might be indifferent between 4 Pepsi and 0 Coke, and 0 Pepsi and 4 Coke. Or maybe there's some other ratio where we like Pepsi twice as much as Coke, but we always have this constant rate at which we're willing to substitute one for the other. When goods are substitutes like that, we're often going to have a corner solution where instead of having an optimal combination in the middle somewhere where we're having some of both, we might end up picking all of one versus all of the other. So if our indifference curve is like this, say we have a budget line that looks like this. This is our budget line. We're indifferent between 4 Pepsi and 4 Coke, but in this case, based on our budget line, it looks like Pepsi is cheaper, so we can afford 4 Pepsi, which means we just buy 4 Pepsi and 0 Coke. And we call this a corner solution because we're over in the corner here. We're buying all of one, none of the other. So we're just spending all of our income on one of the goods, and we're not buying the other good. All right, and then lastly, we have substitution and income effects. This is one of the harder things to understand, I guess, so you can let me know if you have questions. But the basic idea here is going to be, if we look at our budget line, so this is our original budget line. If we get more income, what's going to happen? Well, we can buy more of both goods, right? So if we have more income, our budget line should shift out in a parallel sort of fashion. If we have a change in the relative prices of these goods, that means that we're going to change the slope. And so if let's say that the price of good 1 goes down, if the price of good 1 goes down, if we spend all of our money on good 1, we can now buy more of the good, but if we spend all of our money on good 2, we can still afford the same amount. So if the price of good 1 goes down, this budget line would rotate like this. And so the slope of our budget line changes. That's going to be from a change in price. If we look at like a change in income, that's going to shift our budget line in or out. So more income, we can buy more of everything. If the price of a good changes relative to the other, that changes the slope or the relative cost of buying one good versus the other. And so if we just look at, say, these two here, we can see that when the price of good one goes down, there's really two things going on. One, the slope changes. That's what we're going to call our substitution effect. So just imagine this budget line is rotating like this. We're changing the slope. But at the same time, you can see if we compare these two lines, we can buy more of both goods, especially good one, if the price of good one goes down and our income stays the same. So the part of the price change where the slope changes, that's the substitution effect. Part where we have a change in purchasing power, that's the shifting out or in, effectively a change in income. That's what we call our income effect. So we're going to break up this change in price from here to here into part one, which is just changing the slope, and part two, shifting out this budget line. So the basic idea is when the price of good one goes down, there's two things. One, now the ratio of the price of good one to the price of good two has changed. So the slope changes. That makes us want to buy more of good one. But then also we have this shift out where our income stays the same, but the price of good one has gone down, so we can buy more stuff. Our purchasing power goes up when our income stays the same and the price of one of these goods falls. And so we effectively have more real income. And so that can also have a separate effect on how much we're buying of these two goods. How much more do we want to buy of one good versus the other when we effectively have more income? All right, so we'll be a little bit more brief when we look at these last two. But as we look at elasticity and demand, the basic idea here is about sensitivity. And in particular, we're going to focus on one important elasticity, which is the price elasticity of demand. So we want to think about the sensitivity of quantity demanded to the price of the good. So as we raise the price, how much does the quantity demanded decrease, or vice versa? And this is important to know if you're trying to manage a business and thinking about what's the optimal price to set, or how much do we want to produce of our good. If we have some market power, we have the ability to set our price, which we'll come back to later when we think about market structure and the competitiveness of markets. But assuming we have some ability to set our price for our product, we need to think about this relationship between price and quantity demanded. And to understand how much the quantity demanded changes when we change the price, we need to think about this elasticity. And so this price elasticity of demand is really going to be this formula here. So the elasticity equals our percentage change in quantity demanded divided by the percentage change in price. And so we can look at this at a given point. We can think about the elasticity between 2 points in the demand curve, and we'll focus on kind of calculating this later on. So you can kind of look at that. But the basic idea of this measure is it's going to tell us if price goes up by 1%, how much does quantity demanded go down? And so if our elasticity is equal to 3, that means that our quantity demanded would go down 3% when our price goes up 1%. In that case, because this elasticity is greater than 1, we call this elastic demand. It's more responsive. People really change how much they're buying when we change the price. And if we look at like another scenario, maybe our elasticity is 0.5. So in this case, when price goes up by 1%, our quantity demanded would go down by 0.5%. In this case, we'd call this inelastic because this is less than 1. I guess one important thing to note here is that the price elasticity of demand should always be negative, but we do sometimes just ignore the negative sign because we sort of assume that these things are going in opposite directions when we're talking about the quantity demanded and the price. Okay, so why is this useful? Well, we can look at the price elasticity and total revenue. And so our revenue is going to be equal to the price of each unit that we sell times how many units we sell, which is the quantity. And so that means we have to think about two things when we're considering, say, like raising the price. If we raise the price, then the quantity that we sell is going to go down. So these things are going in opposite directions due to the law of demand. And as a result, we want to know exactly how much less people will buy when we raise the price. And so it turns out that we could write it out like this as well, that our change in revenue is roughly equal to change in price plus the change in quantity. And so if we have really elastic demand, then the change in quantity is going to be greater than this change in price. If it's inelastic, we're going to expect this change in quantity to be less than the change in price. Or we can think about this as percentage changes, I guess. Okay, and so let's say we're trying to consider how much we should raise the price of our product. If demand is inelastic, this could be a good idea, right? Because if we raise our price by 5%, then maybe our quantity demanded only goes down by 2%. And so that's going to mean that our revenue is going to ultimately increase, because our increase in revenue from the price going up is greater than our loss in revenue from the quantity sold going down. But if demand is elastic, then the quantity demanded change is bigger than the price change. In that case, if we raise the price, quantity demanded would go down by more than price would increase. And in that case, our total revenue would be going down as we raise the price. All right, next, you can look at some factors that affect the price elasticity of demand, such as, for example, how many good alternatives does the consumer have? Is this a good that they desperately want, or are there some good alternatives that they could switch to if the price goes up? Then we can look at calculating the price elasticity of demand, and so we can use this thing called the midpoint formula to look at estimating percentage change in quantity and percentage change in price. Basic idea here is that if we look at the percentage change in price, our change in quantity, like our initial quantity versus our quantity after we change the price. So I have Q2 minus Q1. And then if we look at a percentage change in quantity, we could just look at this change, Q2 minus Q1, and divide by our starting point. The problem here is if we use this to turn this into percentage change, then it's relative to this Q1. And then if we, let's say we go from a quantity of 4 to a quantity of 6, then we're basing it on this initial quantity of 4. But if we went backwards and went from 6 to 4, we'd be basing it on this initial quantity of 6. And instead of doing that, we're going to use our midpoint. So instead of thinking about the starting quantity or the ending quantity as our basis to get percentage change, we're just going to think about the midpoint. So if the quantity goes from 4 to 6, we'll just look at using 5 for our denominator here. So then what we'd have is our change in quantity over our midpoint. And our midpoint is just the average of the two. Q1 plus Q2 over 2. So if our starting quantity is 4, our ending quantity is 6, the midpoint would be 5. Okay, and then we can look at some more things about marginal revenue, demand, and the price elasticity of demand. So hopefully that'll kind of make some sense when you look at it, but the basic idea is our marginal revenue is looking at how our total revenue changes as we change the quantity, and this is going to be related to our price elasticity of demand for a price-setting firm. So marginal revenue tells us for an additional unit sold, how much does that add to our revenue? Then we can also look at our other demand elasticities. So we looked at the price elasticity of demand, which is our percentage change in quantity demanded over the percentage change in the price. So as we change our price by 1%, how much does that change our quantity demanded? For other elasticities of demand, we can think about how responsive or sensitive quantity demanded is to other factors. So for example, income elasticity would tell us how much does our quantity demanded change in percentage terms when we have a change in our income, which we'll use an M for in the book. Or we could look at what we call like the cross price elasticity, which is looking at the percentage change in quantity demanded for one good as we change the price of some other good. So for example, how much do people change how much they buy of Pepsi when the price of Coke changes? Or how much do people change how much they buy popcorn when the price of Pepsi changes? Those things will kind of be different depending on whether the goods are substitutes or more complements. All right, and lastly, we'll do some estimating demand. And this is useful for thinking about how we could apply this to the real world if we had some data on how much consumers are buying at different prices. The ideal approach might be a more direct method. So we could try like a survey where we ask consumers how much they buy at various prices. There's a little bit of a danger, though, if we are just giving consumers hypotheticals that they don't have an incentive to answer accurately. What we might want to do is instead run like a real experiment where we do some A/B type testing and we try out varying the price and see how that changes how much people buy. Or we could vary like the size of the product to see how that changes things. This probably works better and better the more we have kind of like fancy data systems and algorithms. So Amazon might try out things like this. Of course, there are some dangers here too in randomly varying the prices. So we want to figure out quantity demanded as a function of the price and other factors. So what we'd like to do is we'd like to randomly vary this price to see how that impacts how much people want to buy as we randomly vary the price. One difficulty, though, of course, is consumers may or may not like it if you're just randomly giving them a higher price, or you might have to make sure that you're able to charge different people different prices in a safe way for your brand. But this is an approach that might make sense the more we have more data, like if you're Uber or Amazon or something. Or you could do kind of like a combination of these and do more of like a lab experiment where maybe you give customers some real money or tokens and you sort of see what they would do in sort of a controlled environment. You have to be careful about how much this generalizes to the real world, but this can help us kind of randomly figure out what consumers do with different prices without having to actually do it in the real world. Of course, it's not always possible to directly look at estimating demand, so instead we might have to do an empirical specification. So we'll look at linear regression. This is where it's helpful to kind of look back to chapter 4 at some kind of basic statistics for interpreting regressions. And the basic idea here is we could think about kind of this relationship between price and quantity demanded. So you might have a bunch of data points. I guess this would really be sort of like a downward relationship. And what we want to do is we take our data and we'd fit a line through it that does as good of a job as possible of meeting the data points. And we can use stats to kind of assess how much of this is sort of random noise versus how much of it is really predictable based on this relationship. And so we might look at our quantity demanded as a function of the price that we set. Maybe we look at like the price of other goods. We might look at like the income of consumers if we knew that, or we might look at like the number of buyers. And so we can look at all these factors and think about controlling for some of these things. How does our price relate to how much people want to buy our quantity demanded? And so then we can estimate this for a price setting firm. It's worth considering that this gets a lot more complicated if you're thinking about estimating demand for an industry, because you have to kind of think about the role that quantity supplied plays in this. But if we're just looking at estimating demand for one specific firm that can set different prices, this method might work better to do some linear regression. And then lastly, we can look at time series forecasts, where we're thinking about over time. As we go throughout time, we can look at different data points. Maybe we could look at a variable like sales, and we could think about if this is kind of what's happening to a variable over time, we can try to think about this trend and try to estimate going forward where we think our variable of interest is going. So if we look at like a bunch of data on sales over time, we can have a model that looks something like this. Like we have sales is like a function of time, maybe some other things there. We look at how this is changing over time, and we look at like a linear equation. We have our intercept, we have our slope, and t is our time. We could look at kind of trying to project this just with like a simple linear projection using this relationship between time and whatever the variable of interest is. And then we could look at other things like controlling for seasonal variation or cyclical variation. But that's sort of the basic idea. So I'll leave you with that for now. Let me know if you have any questions. Feel free to reach out if you want some help. And I'll see you guys in our class Zoom session later on.